So, welcome to another episode of BetaTalk. I'd like to thank my sponsors, my guild patrons, who are Primary Pro, UK Radiators, Cast Rads, Wolsey, and Esby. Thank you very much to them. They help me disseminate all the information I disseminate. Today, I'm joined by James Twallin. We've had James on before, and it's probably a couple of years ago now, is it, James? I think
Yeah, yeah, I think it
goes
was.
quick.
Yeah,
Goes quick. And today we're going to discuss all sorts of interesting topics. James has been up to lots of sort of good stuff. You may remember from when I did have him on last week, we chatted a little bit about Tepio because James was involved in the coding for that. But he's been involved, if you've seen James's work on LinkedIn, he's been involved in understanding our gas network and, and pointing out that it's leaking in a lot of places and that methane has sort of a higher global warming thing than CO2. But he's also been up to some other interesting stuff, which we're also going to talk about. He's been involved in an air-to-air system in a church, and he's also been developing a wonderful little device that one of my favourite engineers has been testing. So we're going to chat about that as well. So welcome back to the show, James. How you been?
yeah, fine, thanks. Yeah, I'm very well, thank you.
What topic would you like to discuss first? So I suppose people on LinkedIn have been seeing your stuff around the gas network and some of the leaks. So just explain what you've been doing there and why you've been doing that.
Yeah, so when I was working at Tepio, I was deeply involved, well, more deeply involved than I would like to be because it's quite dry work, but heat policy. So and one of the main things that I was tasked with was just trying to understand EPCs, right? And energy performance certificates. That's the way of describing that acronym. And you'll remember maybe if you've seen one, there's an energy efficiency rating that describes the energy efficiency of different heating appliances on your EPC. So, and one of the let's say nuances of it is that gas heating is very efficient or good, I think, in EPCs. Correct me if I'm wrong. And then stuff like electricity is just rated as very poor. And so and that got me confused. Yeah. Are you familiar with this? You've
Mm,
seen stuff. Yeah. And so why is that? It's because essentially the way that gas is treated is that when it turns up in your house, as far as the EPC is concerned, it's in the burner of your boiler. Doesn't there's no upstream consideration about losses. It just it's in your boiler and then you burn it. And then they have this thing called a primary energy. Anyway, I think I'm getting pretty too far into details. But one thing that irritated me, well, not irritated me, it made me question it was like, hmm, there's there's definitely there must be leaks on gas networks, right? There must be. There's no real way to prove it. Um, but I'll park that thing just for the meantime, and then talk about the electricity stuff. So if you look at the efficiency of electricity on an EPC, it's got all of the losses associated with it upstream. So
right.
you've got transmission and distribution losses, conversion losses, where you're turning gas in a power station
Yeah.
into electricity. And so by the time you've got the energy service of, let's for the sake of discussion here, direct electric, which is what Tepio is. It is a thermal storage battery, but in terms of delivering the energy service of heating, 1 kilowatt hour of heating, as far as the EPC is concerned, more than one unit of energy is needed to supply that. A lot more than one, actually. I won't quote the specific number, but it's a lot more than the 1 unit of heat service delivered by gas. So the prime energy factor for gas is 1.13. So there you go. There's some context. So I was thinking, how can I how can I prove that losses occur? And I was living in Goring. Well, this was later on, but I was living in Goring at the time, and there was which is on the River Thames. It's kind of close to Reading, and there's this beautiful set of bridges with a big gas main that goes over it.
Mhm.
The bridge is must be must be at least 150 years old. But that you wouldn't dare touch it. But all the time, that I was there, there would be intermittent gas leaks on it that would take that bridge out of action. So I thought, well, how can I? This must be recorded somewhere. Let's see if we can do a freedom of information request to SGN, who are the gas network, and and at the time when they gave me back the data on it, something like 300 gas leaks had occurred in 2 years, and then which was kind of what I needed. I was like, look, gas leaks are happening. Surely people should um, sit up and take notice of this fact. With our heating policy doesn't include gas leaks at all. Like and throughout heating policy, the figures of 200 grams per kilowatt hour is generally used as how bad for the environment gas heating is. Um, and nowhere is there any consideration about leaks. So, but yeah, so it's in Goring, you walk along the road and they've dug up the street and you can see in and you can have conversations with the gas engineers, and they're always really friendly and happy to chat. They're always like, "Who is this weirdo talking to me at great length about gas networks?" But it is interesting stuff, and their job's interesting.
Yeah.
And at the bottom of this great big hole is a big cast iron main. Um, and I'm like, how is that? How is that sealed? How do the joints work? And then they're talking to me about how it's essentially either wire, wool, or jute, which is an organic material, stuffed down this like I think they're called bell and pinion joints, and then they would then solder lead around the edges to keep it tight. Um, and it's it's more like archaeology than engineering when they're digging up these problem areas and trying to figure out what's wrong and where the gas is coming from. So they've got quite a big job. But yeah, that's some background. That's like why I got into it. And the kind of responses that I don't think people really want to hear about it, to be honest. That's why I'm being a bit more uh uh persistent with it, because I think there's this the more you have to be a bit more overt about things that need to be talked about, because I think people don't really want to hear that the gas networks are not necessarily um, as I don't know what to say really, because
And not as optimum as they can. I mean,
no,
it's great engineering because obviously historically we've got a great network. We were one of the world's first to build networks.
yeah,
You say the engineers that work on them, and some of them are fantastic engineers. I
yeah,
mean, what you've described there is sort of an ancient way of a joining method that
yeah,
still is being used with the old materials that are transporting gas. Obviously, we've got newer materials like MTPE, which
yeah.
is new. When you say 300, was that just in that area then?
Yeah, I think it was RG8 postcodes, I think. Yeah. And it was quite interesting to see how the incidence of gas leaks happened where people are. And that would probably be unsurprising because gas networks are where people are, but there doesn't that there are it's hard. There seems to me like a little bit of a sampling bias. And I think the gas networks do not have anything deployed at scale where they are actively detecting and measuring gas leaks. There is, as far as I can tell, there's nothing. They've got some initial trials going where they've got a sniffer on a car going around, but they still massively rely on members of the public phoning in gas leaks via the emergency line. So yeah,
And there's
yeah.
no independent body that oversees leaks. I
No,
don't know of one.
no, there isn't. No, no. They've yeah, yeah,
So you've
yeah,
highlighted this issue, and obviously, if we scale that up, you're talking about 300. So the Freedom of Information request did sign up. It flagged up that there is leaks going on. So I suppose across the country, this is a vast number, isn't it?
yeah, 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 yeah.
And
And there's there is little uh little access to the data. I mean, we've spoken about waste before. With wind farm curtailment and stuff like that. But the reason why people can do that analysis is because the data sets are really, really easily accessible. You just can call an API, download the data, do some analysis. But in terms of actual objective measured data from the gas networks about how much gas is leaking, um, there is very little to see. They have ways of saying how much gas is leaking, but that's done through something called the shrinkage and leakage model, which is based off laboratory condition tests called the national leakage test, where they had sections of pipe and they would measure how much gas leaked or permeated through the membranes of those pipes. And then they applied that factor to essentially their network as a whole. So that's what they when the gas networks are quoting how much gas is leaking, it's actually done off the back of a proprietary model that no one has access to. So that's so I'm second guessing. Someone will say we do say how much is leaking and we have an idea, but that it's only based off kind of a a model. It's not. And every time I've asked gas networks like how much gas is leaking with this incident, how much gas leaked, they don't have access to that data. So I'm just left with lots of questions really. And I think yeah.
Since you've been doing these posts on LinkedIn, has anyone from the policy world got in contact with you and said, "Oh, right, yeah, this actually makes sense why you're trying to highlight this"? Because as you've said, the policy world takes into account losses on the electricity, but not upstream losses on gas.
Mm.
And I mean, obviously, you and I know people in the policy world. We're connected to some of them on LinkedIn. Have any of them got in touch with you and said this is a very interesting thing you're doing?
It's to the response has been kind of muted. Yeah, yeah. It would be nice for people to question a bit more. But yeah, it's been decidedly muted. Um, it's because I think there isn't really any evidence, like proper evidence that the gas networks are leaking. Um, like numbers, putting figures on it, because the data flow from from the gas networks to things like the Climate Change Committee, who oversee things like the carbon budget and stuff. That goes through a pipeline that is largely owned by the gas networks themselves. You just have to look at Companies House and see the ownership structures of the people that um, say that the figures make sense. I'm not going to say it explicitly, but it's worth just having a look. Any listeners who are listening and going, I don't believe that. Just check it. Just go on Companies House and see the ownership structures, and also you can go on my freedom of information requests and see how much verification is done by independent overseers on gas leak data, and you'll see that you'd be left wanting, to put it lightly. So yeah.
Because on some of your LinkedIn posts, you've been doing little videos, haven't you? And you've gone around with your sniffer, what we call a sniffer. It's
Yeah.
the methane, isn't it, coming out of out of the ground, under the road,
Yeah.
essentially, isn't it?
Yeah. I so I there's an athletics ground that I like to train at, and every so often I park my car and I'll walk along this section of shared pathway, and I remember smelling a gas leak in May, and I found it before, and I tagged SGN in the post, and I was hoping maybe they'd do something about it. Okay, I didn't call up the emergency line, but I was hoping that someone with some initiative would look at my post and go, "Oh yeah, that's a gas leak. We should do something about that." Maybe they did. Maybe there was resource constraints. Who knows? Anyway, 6 months later, I'm there again, and it's leaking still. And then I did a video. And I was like, this has been going on for 6 months. Has anyone done anything about it? No. Is anything unusual about this location? No. So you can kind of say, well, if this is something that is an unusual location, you could probably say it's fairly ubiquitous across the entire network. Or unless I can see otherwise, it would be fairly uncontroversial to make that assertion
Mm,
that this is something that's not unusual. And based on the data that I've got back, it is not isn't it is fairly common gas leaks. But it's really interesting if you think about like actually the age of the gas networks as well, like the history of them. Because I was just doing some reading before this and going, how old is when was the first gas network working? And the first gas network, or let's say was they were generally for lighting.
Yeah,
Westminster Bridge had gas lighting in 1813.
yeah,
So that's before the Battle of Waterloo.
yeah,
It's before the first railway network came online in 1825. So like, and as far as I can tell, there hasn't been any wholesale replacement of those existing lighting gas networks that were put in the early 1800s.
yeah.
Like, unless someone can show me evidence that we have dug up, most of our heritage locations and know exactly where all of those original gas pipelines were, um, it's not necessarily we've got a bit of a tapestry to describe it. Our network is a tapestry of lots and lots of different ages, materials, um, and also we've had two world wars. Can you imagine parts of our network were probably bombed? We probably had temporary diversions, probably as temporary as those porta cabins you have in a school. Like 50 years later, they're still there. Um, so so yeah, like can we say with certainty that we know where everything is and we know what everything is made of? Um, I don't think we can say that with great like it doesn't seem to me to be the case that we know where everything is. Um, and it would be nice to be told that we do know where everything is and we know exactly what's going on. But yeah.
Yeah, I mean,
Yeah.
some of them are ancient structures. I mean, don't get me wrong, it's fascinating engineering. Like I say, again, sort of world first
Yeah.
stuff.
Yeah.
Same with water mains, So, I mean, when I used to teach my students about the various parts of a water main, what they're called, so you've got communication pipe, service pipe, but you've also got something like the trunk main.
Mm.
It's called the trunk main because it was hollowed out trunks back when people started laying networks in America and this country. They were hollowed out trees.
Yeah.
Uh,
Yeah.
hence the word trunk main. So,
And
has anyone from any of the networks picked up on what you're doing from your posts and sort of got in touch with you and want to sort of work on it, or have they just been ignoring it?
um no, no. I probably am not particularly popular with them at the moment, I don't think.
I
Um
suppose that
yeah.
sort of stems from also, as you know better than most, there's been a discourse around they want to start transporting hydrogen, or there was proposals to start transporting hydrogen down our networks, wasn't there?
Yeah. Yeah. I just I mean I don't really need to say it. There's plenty of bodies of evidence to say that
Yeah.
that hydrogen is expensive, inefficient. I think it's the explosivity limits of hydrogen as well. It's rather than 5 to 15% with being with methane, with hydrogen it's up to 75%. So unlike with methane, it doesn't choke itself. It explodes over much wider bands. So it's it's it would be a public safety risk as well, and of course the workers who are going out fixing the leaks as well. So um, there's plenty of stuff to talk about, but I don't need to say it. You can just look on someone like the Hydrogen Science Coalition, a group of independent experts with
Mhm.
this. And I think it's also like I spoke to my dad who used to live in London. He grew up in on the outskirts of London in the 1950s, and he remembers the smogs in when people were using coal,
Yeah.
right? So of course, a great deal of benefit has come from the gas networks. People moved to gas from coal. People used to die from those great big smogs in London. So of course, there have been great benefits from what's happened, and also there's some other stuff that's really interesting. Is that did you know that only 5% of properties had central heating in 1960?
Yeah. Oh, yeah.
Yeah, yeah, yeah.
Yeah.
Right. It's absolutely.
Well, we didn't get it in the home I grew up in until 1981, and bearing in mind I come from a family of heating engineers, so yeah,
Yeah,
1981.
yeah.
Until that, we had coal fires and then an electric plug-in heater if it was really cold in winter that my brothers and I would have to get dressed for school in front of. My brother's got a burn mark on his bum from it actually, because I think we
Ooh.
were fighting in one. pushed one and fell on it on the
Yeah.
electric. But no, and paraffin heaters when I was very young in the 70s. But no, yeah, so central heating, yeah, I suppose boomed in the 80s, and but yeah, no, then our first boiler was an anthracite central heating boiler, and no,
Yeah.
and
Yeah.
you talk about the smog, yeah, I mean that's the reason why my whole family, so all my great uncles, my grandparents are EastEnders, and that's the reason they moved to Southend to get away from the smog.
Mm, mm.
Yeah,
So it's
yeah,
in living memory.
definitely.
Yeah. Yeah. So it's I think it would be so the gas networks are not all bad news. I'm not like going to say that but it's some big changes of in heating have happened. Even in the from the 1960s onwards,
Yeah,
we had the entire housing stock essentially, and council houses didn't necessarily have to have central heating until I think 1969. So most and also we forget that a large percentage of our housing stock was council housing,
yeah,
like up to like 33% or something. So a huge amount of government spending went into putting central heating in people's houses. Probably in today's money, hundreds of billions worth. It's a massive change, and so I think there's a lot to learn from that those kind of schemes in today's world because people are saying, oh, heat pumps can't happen. It's going to be really expensive. Well, I think that's partially because um, we've now got private landlords owning quite a lot of our council houses as a result of this lady who allowed everyone to buy their houses. Um, and then and so now it's being done not through the public purse, it's more done through private money and
yeah,
obviously subsidized by the state as well. But
yeah.
similar scale of challenge, I think. Yeah.
Yes, yeah,
So
definitely. So let's go on to heat pumps there. So you've been doing something interesting with a local church, I suppose. Is it a local church you've been doing this with, or is it?
yeah,
Yeah.
yeah, yeah, yeah.
Tell everyone
Um,
what you've been up to.
um, yeah. So lots of people will say, "Oh, heat pumps don't work in big old buildings." So I thought, well, let's obviously that's not true. So let's put a heat pump in a church and then and really talk about how it was done, the performance of it, and yeah, and hopefully give people some good news, basically. Because I asked you actually about let's start from the beginning, shall I? So um my where I grew up is in near Newbury, and there's a church called St. Martin's, which my parents are still involved in. And my dad has been like involved in it for a long time as well. It's a Church of England church. It's 200 years old. And he was tasked with trying to get a replacement for the heating system. And the heating system was essentially a big cast iron convection style thing that just burned oil and then radiated heat through some fins.
Mm.
Again, probably installed late 19th century, so extremely old. Um, and so the Church of England has a net zero thing for 2030. They want to do clean heat. Um, well, they want to. The biggest thing is probably scope one emissions, which is burning things to keep the spaces warm. Um, so during this process, he was getting quotes for different things like a heat pump, infrared heating, essentially bar heaters. Um, and and as you're probably aware, the MCS heat loss software or the MCS approach of modeling heat loss is assuming that the building is heated in steady state, which is not the case with a church. It's well, not the case with all churches, but this church in particular is used once or twice a week. So running heating all the time would be expensive. So so it was really useful to actually try and do a physics-based model of the church, and see what was going on. Is this kind of making sense so far?
Yeah, yeah, yeah.
Structure? Yeah. So um, thermal mass is really important for intermittent heating, because unlike with steady state heating, where you assume that the thermal mass is essentially saturated, um, with intermittent heating, you're charging the thermal mass and hoping it doesn't leak out, that the heat doesn't leak out before it's up to temperature. That's kind of how it works, right? Um, so so what so what I did is I wanted to work out the thermal mass of this building
Right.
so that we could size this heat pump correctly.
Right.
Um, and how do we do this? Well, what I did is I put a temperature sensor in the building and just measured the internal temperature with respect to the external temperature.
Yeah.
And so what you can see is how steady the internal space of a church is when you've got these massive fluctuations in temperature outside.
Yeah.
And that's because it's an enormous it's like an enormous it's an enormous block of stone. It's like you'll be familiar with going into something like a big castle or a church in a bright summer's day. Like imagine you're on holiday in France and you're looking at this amazing big castle and you go inside and it's absolutely stone cold. Even though it's like 35 degrees outside. Churches are the same.
Mm.
Um, uh, and so sizing a heat pump for something like that is an interesting challenge.
Mm.
And the first thing you need to do is with anything is map it. You've got to map the problem. So let's try and explain this.
You had temperatures when you say temperature sensors. Did you put them in a variety of places, or you just had sort of one central sensor, just getting
Yeah, just
an
one.
idea of what your internal temperature was?
Yeah.
Yeah.
Um, So what we want to do is we want to make a model where the model temperature matches the observed temperature of the church that you're seeing. Because if you can do that, then you've got a good handle on the thermal characteristics of that building. So that's what we did. And then the model itself is, and I'm going to describe this in great detail so that because it's physics and you shouldn't be able to patent stuff like this. It's important that this is out in the open,
Yeah.
so that I can so that anyone listening can do something similar.
Yeah.
We're in a climate crisis. It's important that we do this. Um, so let's describe the building. Essentially it's a big rectangle, a big cube, with walls for thickness that might be X thickness. You can measure this. You can probably say it's this much. Um, and that wall itself has thermal capacity per kilogram. It has thermal conductivity. Um, it has density, um, stuff like that. And so you can play around with those parameters and start iterating around and seeing how if you can get a model of that building to fit with the observed data that you're seeing. The other thing that's also useful is that last winter we had a propane burner that was of known heat output as well. So it was a 70 kilowatt burner. And my dad very carefully kept a heat diary of like when it went on and when it went off. And so we knew how many joules were going into the thermal mass of the building. So that was really useful as well. So that was another way of constraining the model.
Yeah.
Because if we knew if we knew how long the burner was running for,
Yeah.
and we knew how much the temperature was increasing by, we could then kind of work backwards and understand the thermal parameters of the building from um, from known inputs. Yeah, cool. So that's cool. So we got a model that was like working really well. It was we'd run the propane burner, we'd watch the temperatures go up, we would run that through the model, and then we'd get the same response that we saw. So that was like, okay, we've got the thermal characteristics of the building dialed in. We also added things like solar gain as well, and the size of the windows. Yeah, and so at that point, we have this kind of heat loss model, and also what we also did is we'd run it so that there was a consistent. Imagine if you had to, we had a thermal model that was in software that we'd constrained. We then compared how much heat it would take to keep that building at a steady temperature, and luckily, and as a sense check, the numbers that we got roughly aligned with what the MCS heat loss calculation was saying. So we could be kind of confident about that too. And then we're like, okay, air to air, which you recommended. Thank you for that. Because we thought about doing for the very initial stages, air to water was one thing that we were thinking about, but that was put to bed when I spoke to you about air to air for heating a space. So yeah, we modeled varying inputs of heat power for an air to air heat pump, and we then landed on the kind of conclusion is that you want to get the heat space. So you want to get the space heated before the thermal mass gets saturated and then starts transmitting heat out into the atmosphere. So we've got the single phase connection and we maxed it out with a 50 kilowatt set of heat pumps. We're not maxed it out. I think it doesn't use nearly as much as 20 kilowatt hours, 20 kilowatts. But yeah, that's what we landed on. It's working really well. Yeah.
Did you go multi-split or mini splits?
Yeah, multi-split.
Yeah.
Yeah.
Which manufacturer did you use?
Dakin.
Yeah.
Yeah.
And that's now been in, hasn't it? For well, it was in last winter, was it? Was it in last
Well,
winter?
yes, it's been running since October.
Right.
Yeah. And yeah, it's working really well. Yeah. It's what is interesting though is that you have to before you run it, you have to look at the external temperature the outdoor temperature, the internal temperature, because we're running it intermittently. So we have to run it in advance. And so the COP, the amount of temperature lift that you need, all that stuff means that to your end point of 17 or 18 degrees internally, which is what we're aiming for, it has to be planned. You have to run it for 9 hours or so on a typical day, and sometimes a bit longer, let's say 18 hours on -1 degree day. So yeah, so I wouldn't, to play devil's advocate, I wouldn't say it's a particularly fire and forget thing like the infrared three phase connection style thing you might need. But the fact of the matter is that with some automation and with some automation, I think we can get to a system that's really easy to use and cheap as well. Cheap. Like that's the other, yeah.
Yeah, I don't think people realise how cheap air-to-air stuff can be compared to
Yeah.
other technologies. I mean, like you talked about infrared. I mean, infrared is quite expensive stuff sometimes, and
Yeah, you've got to do the three phase upgrade
yeah,
and then for comparative running costs, someone I know who put infrared in a church, their running cost per service is about 60 or 70 pounds. Whereas comparatively running an air-to-air heat pump system like the one at St Martin's, it's about 20 quid for a typical service. So it's 3 times less, obviously. It would make sense, right? Because you've got the COP. But I think air-to-air as well also gets much. I think it's up at 5 sometimes. It's really, there's quite a big notable difference in performance when it's mild outside
yeah.
versus when it's really cold. Yeah.
Well, there's some work currently going. I think, I mean, you may have listened to the episode I did with John Eubank. He's sort of currently doing some testing with Tristan actually and Glyn, I think, from Open Energy Monitor
Yeah.
around air to air. Interestingly, I mean, I don't know if many people know this. The church was very significant in the history of heating.
Oh
Uh,
yeah.
Very. So if you go back to, so before SIBSE, and it's just completely gone from my head, there's another acronym. So basically the Heating and Ventilation Institution that predates SIBSE. If you look at the old firms and companies that were involved in that back in the 1890s and onwards, they were companies that were heating churches. So that whole thing, obviously, like you mentioned earlier, central heating wasn't a common thing in people's homes. But heating churches is kind of where our heating industry grew from. So obviously back in the day, we got 200, 300, 400 years ago, everyone congregated at a church of some sort. That was part of society. So if you look at where I've grown up in Norfolk, the Broads, I don't know if you've ever been on the Broads, beautiful, beautiful part of the planet, really. A lot of people thought the Broads were natural. They're not. They're man-made. They got
Mhm.
man-made about in the 1600s. They were people dug the peat to heat the churches because Norwich at the time, oh, my history's rubbish, but I'm around about the 1600s. Norwich was the second city in the country. It had a very, very, very successful cloth and wool industry.
Mm, mm,
That's where worsted cloth comes from. So massive, massive, lots of money coming into Norwich. Hence, lots of churches got built. I mean, Norwich was famous for a pub for every day of the week, 365 pubs, and a church for every week.
mm,
I've worked on roofs in Norwich, and you can literally you stand on a high roof and you can see 20 churches easy. So obviously these churches needed to get heated. Now the cathedral in Norwich is a beautiful building, and back in the day, obviously going back to the 1600s, there was lots of woodland, more than what we've got now, but it was getting chopped down very, very, very quickly for fuel. And then I think people realised our navy's more important to build ships with that wood rather than burn it.
mm,
And so they started peat excavation. So that whole broad system, which is huge, is all peat excavation. And it flooded in the sort of, I'm going to say 1800s, probably got my history wrong. But once it flooded, because sea levels rose or whatever, the people started to then think it was a natural thing, but it wasn't. It was man-made to heat churches and to heat cathedrals. So the whole heating industry, if you really dive back into the history of it, right back, it's from heating churches.
mm, mm.
I don't know if the Church of England are aware of that when you mentioned their whole net zero policy, but they were instrumental in some of the real good science around heating that was going on because this again, we were world leading in heating if you go back to them sort of times. And a
Mm,
lot of the science around heat and it sort of stems back from the church. I didn't know
mm.
whether the Church of England actually knew that. Have they been interested in what you're doing with this book?
Yeah, they're keeping an eye on it. Yeah.
Good.
Yeah. And I think, yeah, there's been quite a lot of, it's been very positive. It's a positive thing to say that a heat bulb's working in a church because it's really, um, it pushes back on this narrative that they're not good for old buildings and they're not good for uninsulated buildings. I mean, the church that the heat pump's in is totally uninsulated,
Yeah.
and I think also the other thing is that the the whole condensing a barrier down to just a simple thing like a U value as well. I did that. That is a thing that we need to move past because you can have a thick wall with a different thermal conductivity, and it might have the same U value as a small wall with a different thermal conductivity. It's kind of interesting, but we need to model thermal mass in buildings, in particular for things like peak avoidance, because when the whole when our heating stock becomes electrified, we're going to have to do an element of demand shifting, and if we can move heat earlier on in the day to avoid the coldest period of the day and ride out those peaks. Not for everyone, obviously, the houses that don't have any thermal mass wouldn't be partaking in this. But let's say, like I know that Glyn, he lives in a I believe according to his post on Open Energy Monitor, he lives in a like a big stone Welsh house, and you can. And I advise anyone to look at this they've got this heat demand tool where you can see the straight line stuff. The clearest manifestation of thermal mass is the scatter because because essentially if you think about it, um, if you have a house that has no thermal mass, the energy that it needs to heat that space is going to be directly proportional to the temperature outside because there's nothing to ride through it. But if you've got a house with a lot of thermal mass, then the heat energy required to heat that space is also a function of what came before it too. And so you get this big scatter. There's not a one-to-one relationship. So,
Mm.
and if you flick through the houses, you start to notice that the houses with the thick stone walls have got a big scatter to them. So I don't know if anyone's noticed that before,
Are
but
you on Are you on the OEM forum? Because they've got a great forum where all you geeks and that chat about.
no, I'm not. But I mean, it's a great tool. It's a great tool,
Oh, it's
basically.
brilliant. It should have
Yeah,
won an award by now.
yeah.
No, churches, yeah. I mean, my cousin put a system in. I'm going to say the 80s. Annie Lennox and Dave Stewart. If any of the listeners remember them, you
Of
admit
course.
they
Yeah.
bought a church back in the 80s and turned it into a studio. And my cousin put air-to-air stuff in that. I do think it still has the old system in it. Some of the radiator system, but it's predominantly heated with the air-to-air stuff, and it has been for a good few decades. And I pulled the fan core units up to the roof. I broke my ribs doing it because I was pulling one. I mean, air-to-air units are lighter than I don't want anyone thinking I was like that strong where I could pull a heat pump up to the roof. But air-to-air stuff is a lot lighter, especially the smaller mini splits. So me and my cousin had ropes on either end. We were pulling them up, and we hit a ledge, and the unit dropped, and I moved forward, and I banged my ribs on one of the upstands of the scaffold handrail, and broke my ribs. But yeah, and that's recorded. Some of the world's most famous musicians
Yeah,
playing at
yeah.
that church, and none of them complained about being cold.
Did it need to be quiet as well?
Yes, of course. Yes.
Yeah.
So I suppose my cousin's the leading engineer in the country for acoustic sensitive stuff.
Hmm.
So things
Hmm.
like the BBC record studios. So lots of radio stations that have had naysayers come on in interviews and say heat pumps don't work. They're sitting in studios, temperature controlled heat pump systems. They have been for decades. Um, Lots of post production studios. I put the system in at Pinewood where the machines developed Star Wars and James Bond.
Yeah.
Uh, first, the first Mitsubishi R2 system. If anyone knows what an R2 system is, we put that in number one Soho for Paul McCartney at his offices.
Wow.
So it's been going in everywhere, air to air stuff.
Yeah.
And yeah, it's a technology that's everywhere. It's ubiquitous, but most people don't realise what's heating them outside their homes. Why would they? They've
Yeah.
got better things to be thinking about.
Yeah.
Um, and obviously, when it comes to homes, our country and policy has tended to focus on air to water stuff,
Yeah.
not probably realising how cheap air to air stuff is.
I know. Yeah.
Really cheap.
Yeah.
Um, which brings us on to another topic. You've got this lovely little device, and you've been working. Oh, he's a love. I'm going to give him a shout out, David. David from Falcon. Is it what I'm trying to think? What his company's called? Falcon.
Vulcan. Vulcan heating.
He's a
Vulcan renewables.
he's a great guy. I've met him and his wife. They're a team. That their company. A lot of people forget that behind some of these engineers is the partner helping run the company. And David's a fascinating engineer. I really, really like the work he does. And you've got this little device, and I
Mm.
love this. You can put it onto a boiler, and it's going to give people essentially information of whether they're heat pump ready. So just describe what you've done there, because I think it's great.
Yeah, I mean, so you can look at heat demand by looking at your gas data. That will tell you how much power is required to heat your house on, say, the coldest day of the year. That's part of the picture. But really, what is your heating loop doing? So this sensor, it clips onto the flow and return pipes of your gas boiler. It measures the boiler run times and also the flow and return temperatures of your heating loop. And the simple heuristic is if you're running your heating system like it's got a heat pump, then in theory, there should be minimal changes needed, apart from obviously you might need a cylinder, to put in a heat pump, right? That's the idea. So the first thing I'm doing is just getting the idea validated with people like David, to say, is it useful to installers? And yeah.
I like how it's so correct me if I'm wrong. It senses vibration, so it knows when your boiler's started up. It knows when your boiler's off. So because as you may know, I'm a big critic of how we control boilers in this country. It's a lot on-off switching. I'm a big critic of Hive and their marketing. They've started sponsoring my favourite podcast, uh, all about history, which annoys me because I have to listen to them banging on about Hive. Great presenters. The rest is history. I don't know if you know that podcast. It's fascinating.
Yeah, yeah, yeah.
But every time they start going on about Hive, I'm thinking, oh, God, crikey, if only you really knew the history of heating.
Yeah.
You're promoting an on-off thermostat. And
Yeah.
our boilers, so I've just moved into a new property. It's rented, and that boiler's going on and off about 90 times a day easily.
Yeah, 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 yeah.
Ain't good for it.
Yeah.
And so your little device is going to be able to sense that. It senses how
Yeah.
many times a boiler's switching on and off. It's
Yeah.
sensing the delta T between flow and return.
Yeah.
And it's going to give people a cheap way, I suppose, isn't it, of understanding if a home is heat pump ready.
Yeah. That's the idea. Because I think so. Heat loss surveys at the moment are expensive, and people know that, right? They cost
And,
something around about 300 quid.
and they're not accurate.
No, exactly. Well, yeah. Yeah, they're not based on data. They're not based on nominal operational data. And so like are you if you put a sensor on your boiler and you can say subjectively that you're happy with the heating system and you're running it at flow temperatures that like a heat pump, then I think you can be fairly confident that that a heat pump will work.
Yeah.
Yeah, so it's kind of it's going from the ground up. It's going off data that is generated by the customer. Yeah,
And it's a
yeah.
piece of little hardware it's quite simple for someone to install themselves. They just clip it on something.
Um, that's the idea. Yeah, I mean the the aspiration would be something that that it's cheap enough, simple enough to throw in the post, and hopefully with some guidance via a YouTube walkthrough or something like that. I mean, people tiling their bathrooms with with let's say YouTube videos, so I'm sure they can just stick a sensor on onto some pipes. Well, I don't know, but we'll see. We'll see.
Are you ready? Are you at a stage, developmental stage, where people can ask you for this device yet? Have you just got the one that David's using and trialing at the moment?
Well, I've got a few prototypes that deployed with installers. It is a prototype. It's not ready for the public market yet because there's some processes that I need to do. I think at some stage I probably will need to um, get some money to make it a proper product because that's not cheap. But I think part of this process is just validating that it's a useful thing and could because I don't know if I already described it, but the prototype of this thing, but I won't be able to show it to listeners, but that was used to size the heat pump in the church.
Yeah.
Um, the software stack and the version of it because there's a whole lot of stuff behind it too. It's like there's an app with it and a whole load of
Yeah.
infrastructure with the software. So yeah, it's not just the sensor; it's all of the other data science in the background. That's
Well,
more.
the data is interesting because you could, let's say lots of people had this around the country. The data you could collect, building archetypes, locality, does that have an effect on heat pump ready?
That
The
would be ideal. Yeah, yeah,
actual hardware, I mean, that's got a lovely, fascinating, beautiful story behind it because it's your cousin helped you build that prototype, and I think your cousin, for any of you that are old enough to remember Robot Wars, is it Robot Wars that was on the
yeah.
telly?
Robot was yeah.
Your cousin was involved in that. He
Yeah.
made one of the champion robots, I think, didn't
Well, yeah, kilohertz.
he?
Yeah, yeah.
Kilohertz.
Yeah, well, because I was a bit stuck with essentially a dev board and a whole load of wires. I'd proven the concept, but then I thought, well, I need to get this into something that I can that someone can handle now. So I just texted my cousin John and was like, "Do you have any experience with making PCBs?" And he was like, "Yeah." So I just turned up at his house, gave him the tangle of wires in the dev board and a couple of sensors, and then before I knew it. He'd made the prototypes for me, which is amazing. So that's made it so much easier, and he can just make tweaks, and it's really really great to know someone like him.
Well, the
Yeah,
name of his robot is actually quite pertinent to our industry in a way, isn't it? I mean, there was
yeah, kilohertz.
the
Yeah,
robots had all sorts of names, didn't they? The
yeah.
ones that were competing, but
And he had one called Beta and Terahertz, and yeah, yeah, pretty cool.
so
Yeah,
that's fascinating. So I think that's a great little because we don't get too much data from the boiler. I mean, Bosch had 4,000 heat pumps being monitored, and good on them. That data went to people I know at DESNES, and some scientific studies came from that. And actually, that data sort of said similar things that a lot of people's emitter systems in their homes are quite capable for heat pumps.
yeah,
What that data, the data interestingly also showed up that all these 4,000 boilers are controlled with on off.
yeah,
And
yeah, yeah,
as one of the sort of policy people I know in DESNES said, am I allowed to say this?
yeah.
I think what was pointed out is it's interesting how in Germany Bosch don't even have a switch live on their PC. They're controlling their boilers different. It's the UK that like this on. We're obsessed with on-off control.
Yeah, I've heard about this. Yeah, Yeah, apparently we don't get the good stuff in the UK.
Yeah, I mean, boiler manufacturers won't like me saying this, but the same model boiler for different places in Europe isn't exactly the same. So the
Okay. Yeah, I
factories
see what you're saying.
don't make them
Yeah.
exactly the same.
Yeah.
So if you've got, let's say, for instance, if you've got a massive market like the UK is, it's the biggest market in Europe, where you're selling loads and loads of boilers, you can get away with putting cheaper bits and components in than, let's say, the ones you're selling in Germany, which is the same model, same make number. It's just for the German market as opposed to the. And of course, then we got the problem of all the manufacturer's instructions being translated in a good way.
Yeah.
There's
Yeah.
big problems, I think, with manufacturer's instructions at the moment. But yeah, your little device, where people, I suppose, essentially you could call it DIY, couldn't you? So your early adopters wanted to think about heat pump technology that are obviously bombarded with information and myths and all this kind of stuff. They can just put this device on the board and think, oh, right.
Well, it is a massive, it is a potentially massive market, right? That we've got 1.3 million boilers installed every year. It's enormous,
Yeah.
and a lot of those boilers are going to be distress purchases where people have their boilers conked out. They don't have time. Sorry, the heat pumps want that, don't really care. Really, that's the reality of it. So we need to have something that can get between the distress purchase. We need to get something that is low cost and simple enough that we don't have to have any people involved. We can just throw it in the post, they can measure it, and then hopefully by the time their boiler is broken, they've already got a lead for a heat pump installer who knows exactly what they need to install.
Yeah.
They know that the radiator systems are pretty much there. We can then we can start really, really pushing out this figure of 60,000 a year, which is where we currently, and obviously that doesn't include lots of other installs, but according to MCS, we're round about the 60,000 mark per year for heat pumps, which we need to find a way of expanding.
What you
Yeah.
said there has really interested me. So yes, your data, because you're the sort of data, well, you are a data scientist. So your app, API app, whatever what you guys call it. So that's collecting data. So someone that has a boiler that breaks down, but has had one of these things monitoring it for, let's say, a couple of winters, it can send, so let's say my guild engineers, the engineers are in the guild of master heat engineers, it instantly pings up to them in that locality. This is a green flag. This is a go. This could easily have a heat pump because we can see that it only needs sort of maximum temperatures of, let's say, 40 flow and
Yeah,
think.
that would be amazing, right? To get to that stage, yeah. Yeah. Obviously there's a lot of uh assumptions baked into that. Like is let's say we have a user who's got a gas boiler, they're running it at 70 degrees. We have to somehow get them persuaded to run their flow temperature lower, make their thermostat run for longer, get them to a stage where they're heating their house like it's a heat pump. Hopefully we can get to that place. But then, yeah, if that person then their boiler breaks down and they've had a sensor on there, we'd have like a lead, a pre-certified lead for an installer. Yeah.
That's very interesting because the government had their heat pump ready fund that ran for a couple of years, and it was all about our homes heat pump ready.
Hmm.
So lots of consortiums. I think there was 26 in streams too. Were coming up with ideas that were testing, got funded to test, and interestingly, none of them sort of did. I don't think any of them, because Carbon Trust, I was involved with Carbon Trust to report on all these consortiums and what they were doing, and I don't think any of them actually ever monitored the boiler.
Yeah.
Some of them, like Build Test Solutions, had deployed their technology to sort of measure temperature, measure HTC, heat transfer coefficients, and stuff like this. But I don't think any actually looked at what the actual current heating from a temperature point of view they did, but not like put it onto the boiler. Right, how's your boiler? I mean, you were talking about how do you incentivize people, because at some point you want them to sort of turn the temperatures down to sort of get an idea, don't you?
Mm.
Where I suppose things like nudge comes into it, gamifying. I mean, that they might be on a nappy that turn your board. This is what the temperature is going to be today outside. Can you turn your flow temperature down to this? And like I say, if you've got 1,000 deployed, that's giving you great granular data.
Mm. Mm. Mm.
Really interesting. I mean,
I think it's
I've
the
always been
data that,
surprised why none of the boiler companies did anything like this, just to give themselves a bit of a marketing edge over others, because they're all getting into heat pumps. If one of the boiler companies had been doing this, it makes it so much easier for society to, and of course, then let's say Valent did it or Bosch had been doing it for a couple of years. I mean, maybe that you should approach them. I can help you find the right, because they might be able to license your product from you
yeah, yeah.
and get it out to their, because I've got huge customer bases, and get it out to certain customers. Um,
Yeah, I'd like to work on it full time. Like it's something that I'm doing on the side. Um, so yeah, I'd like to work
it
on it full
always
time.
amazes me why we're not collecting more data. Like I say, we've got the biggest boiler market in Europe. Like you say, you mentioned 1.3. I think our biggest year was 1.9 million boilers
Mm.
on our most successful year. Um, 26 million boilers, I think, gas, and yeah, we could be collecting all sorts of data from these things, and
Yeah,
we don't.
yeah,
And I've
yeah.
just done a news. One of my newsletters recently was about how the big four, Worcester, Bosch, Valent, Baxi, and Ideal, have just announced their January loyalty scheme. So the whole newsletter, the premise of my newsletter was we're incentivizing a replacement culture rather than repair culture. So engineers, if they put in so many boilers a year, they're going to get flown on skiing trips and
Yeah, I know, right?
they're
Yeah, I
going to get
saw that. Yeah.
cashback incentives. And come on, you guys, we're not incentivizing what we should be incentivizing. We want to be incentivizing efficiency and
Yeah.
sustainability. If you can keep that boiler going for a little bit longer, that's a
Mm,
sustainable practice. Trying
mm,
to convince people, if you go into a customer's house, the boiler's 7 years old and you can get away with replacing it and you'll get more points on your loyalty scheme, that's not really what we should be doing.
mm. Yeah,
Um, we
yeah,
should be doing things like more like what you're doing is like, right, let's understand that property via the boiler.
yeah,
Yeah, we got the flow
yeah,
and return temperatures, we've got the on and off signals. Let's do something very simple. It's seamless. No one's having to pay £300 for someone to come around and do a heat loss survey, which is I think Steph from Spruce are sort of my favourite one at the moment. But they're very honest. They said it's an estimated heat loss. Um,
mm,
it's an
mm.
estimated calculation. It's not nothing set in stone with U values. It's a very
Yeah.
sort of finger in the air type thing of doing it.
And you can look at a wall, but if you stand by it, you might discover that there's an enormous draft because there's actually a hole in it that you haven't noticed. And like, so do you values capture that? No, they don't. There's all these things that unless you actually measure the data, you actually see what the house is doing. You don't get a proper insight into what's actually going on. So
Hmm. Going
yeah.
back to your church, has your church got an organ in it?
Yes, it has, yeah. Yeah.
I mean, I don't know anything about. I used to listen to this. Was it? I can't know. It was a BBC4 program years ago, and the presenters used to go around different churches, cathedrals in the country to look at the organ. I mean, these are fascinating machines. These organs,
Hmm.
like
Mm,
in their own right,
mm,
beautiful, beautiful pieces of engineering, actually.
mm,
And I can't remember if they're supposed to be kept at a certain temperature because I don't know how the reeds work inside them,
mm,
um, and obviously expansion and contraction of metals might make the tuning go out.
mm.
That's always interesting. I've never really looked into it, but
I know it has to be tuned periodically. Yeah.
I mean,
Yeah.
some of these are beautiful, beautiful machines. Some of these
Yeah.
in European churches, actually.
Yeah.
And I mean, that's another interesting fact about Norfolk. Norfolk and Suffolk have the most density of churches anywhere in the world.
Really?
Yeah, I
Huh.
think I'm sure I've read that. And the oldest church in America is a wooden church named after the village that was 2 miles from where I grew up, Hingham, which is where Abraham Lincoln's great 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 grandparent Samuel Lincoln came from.
Wow.
The little school I went to is on the same road as where that church is, where and they've got the Americans actually presented that church with a bust of Abraham Lincoln a few years ago. And of course, it's the anniversary of America, 250 years this year.
Yeah. Yeah. And then not soon after the establishment of America, the gas networks went in.
Yeah, I know exactly. Yeah, very, very. There's a great. I always forget his name. I think it's David. He's a great historian of the gas industry. He's always
Oh
on.
yes.
I,
Yeah.
s- I, s- I
It's not
sometimes tag you in on some of
not
you.
Russell Thomas.
That's
It's
it. It's rest.
yeah.
Yeah, because it is a
Is it Russell? Yeah.
fascinating. yeah, we should be proud of that. I mean, I know some people have a go at the gas and because it's burning and stuff, but that
Oh,
was
it's fascinating.
it
It
was
is so
pivotal.
fascinating.
It was pivotal in with sanitation and helping our society survive. And
Yeah, yeah, yeah.
it's done a lot of good. Put it that way. Burning that gas has done a lot of good historically. We just got to now look
Yeah.
at different ways.
We've now got to move on technologically, right?
Yes.
It's just the natural order of things that things get better over time.
So, Jack, where can people follow you? So they can follow you on LinkedIn. You're not
Yeah.
on anything else, are you? Or have you got a Substack? Or where can people see what you're
I
doing?
do have a Substack. Occasionally I write stuff on Substack. But yeah, predominantly LinkedIn. I find that that's the most let's say constructive engagement platform
Yeah.
at the moment. Yeah. Yeah.
And you said there you'd like to sort of concentrate on developing this little prototype thing you've done for the boilers.
That'd be nice, yeah. Yeah, to do that full time. That would be cool. Yeah.
So hopefully one of the boiler manufacturers will get in touch with you.
Yeah. Yeah. Yeah, that'd be cool. Yeah. Or anyone interested. Yeah.
Hmm.
I think I'm looking for someone who is engaged in heating, maybe some kind of a high net worth individual, some kind of angel investor. That would be a cool person to have just to get the product ready for market. That's what we need to do. And I can't really do it alone. So yeah,
Well,
that's
it's interesting stuff you're doing. Like I say, you keep yourself busy. You've got two young children as well, haven't you? You've got a 4-year-old and a
yeah,
little one.
yeah, yeah.
And I forgot
It's,
you're a runner. You're a sprint. You run
yes, I
for
do.
this club or sprinting or distance?
Sprinting. I run for Wickham Phoenix. Yeah, as a masters athlete. Yeah, yeah.
Brilliant. Well, my little nephew, I say little, he's my eldest nephew. He's 18. He's now won a scholarship out in America. He's now running out in America. So
Oh, congratulations. I mean, that's a very, very shrewd thing to do. Yeah, I know a few young people in the club who've done the same thing. Yeah.
he's loving it, and it's fascinating to me. So obviously, I paid for my degree, and most young people have to pay for their degree. He's got 4 years of doing a degree, all paid for.
Yeah.
All his 4 years of lodging's paid for. All his food is paid because he's on a sort of scientific diet.
Yeah.
So he's cross country. So I think he's the second fastest in the UK for his distance
Yeah.
at his age, and he won a scholarship out in America to run out there. So
Yeah. Congratulations. Yeah, there's a fair few runners who've come through our club who are now studying in America and doing exactly the same thing because of the whole because of education in the UK is now not really. I mean, when you're given the option of what the setup.
oh, I've lost you, James. Oh, there you go.
Sorry, you're still there? Can you hear me?
Yeah, yeah.
Okay. Yeah, there's a few runners in our club who are now living and training in the United States and doing their degree there too. So yeah.
Their whole collegiate setup is fascinating. It's brilliant.
And the facilities are incredible too.
Yeah.
Yeah, that's incredible.
And what sort of distances do you sprint then?
Well, 400,
Oh,
200, 400.
you're a
Yeah,
400 runner.
yeah,
You're
yeah.
pretty fit then.
I hope so. I
Have you
hope.
ever done your VO2 max?
No, no, I don't think so. No,
You should try
but
that. Let me know what it is because my brother, the father of my nephew, he's 50 now and he's got a VO2 max of 63.
well, that's something to aspire to.
That's
Yeah,
that's very very. I mean, I think. Well, he didn't tell me who they were. I don't think he had to sign an NDA, but when he got that tested at, I think it was Harley Street, there was two professional boxers there in their 20s, and he beat them.
yeah.
And
Wow.
he's not allowed to say who they are because it would embarrass him or something like that. I mean, he did tell me, and he hasn't. To be fair to him, he never told me who they were. But he's very super fit, my
Yeah.
brother. Um,
It's
so
good for longevity. So hopefully I'll be there at some
all to
point.
do with energy. James, it's been a pleasure speaking to you again.
Thanks, Nathan.
You have a great
Good
rest of the
speaking.
week.
Yeah, you too. Cheers.
Cheers, buddy.